Lesson 3.6 covers matrix multiplication. Let's begin by looking at the steps to multiply matrices. In step 1, you're going to label the size of each matrix. We're going to use the size to determine if the matrices can be multiplied. In order for the matrices to be able to be multiplied, the number of columns in the first matrix must equal the number of rows in the second matrix. If this is true, then you multiply every row in the first matrix by every column in the second matrix. And you do this by multiplying element by element and then adding all of the products. So let's look at an example. I'm going to begin by labeling the size of each matrix. The first matrix has 2 rows and 2 columns, so it's a 2 by 2. The second matrix also has 2 rows and 2 columns, so it's a 2 by 2. Now in the previous lesson we looked at adding and subtracting matrices, and they had to be the same size. These matrices do not have to be the same size. You have to look at the number of columns in the first matrix and the number of rows in the second matrix. The number of columns in the first matrix is the second number in the size, and the number of rows in the second matrix is the first number listed in the size. So basically I'm comparing these two middle numbers. They must be equal. Since these are equal, I can multiply these matrices. Now the outside numbers will tell me the size of my answer. Since the outside numbers are each 2, my answer is going to be a 2 by 2 matrix. So once I determine that these can be multiplied, I'm going to use the rows from the first matrix and the columns from the second matrix. So to help me, I just circle the rows in the first matrix and I circle the columns in the second matrix. My first row has to be multiplied by each column. So I'm going to multiply row 1, column 1, and then row 1 by column 2. Then I have to multiply my second row by each column. So I'm going to multiply row 2 by column 1 and row 2 by column 2. I suggest you write this out instead of trying to do it in your head. Write it out and label what you're multiplying, because this is going to help me when I'm ready to put in my answers. Well, row 1 contains the elements 2 and 4. I write each of these elements with a parenthesis behind them. So 2 times some number plus 4 times some number. Inside those parentheses, I'm going to fill in the elements from column 1, which is -3 and 4. For row 1, column 2, row 1 is also 2, 4. So I write the 2 followed by a parenthesis and the +4 followed by a parenthesis. This time I'm going to fill in my parentheses with column 2, which is -5, -2. Now row 2 contains the elements 5 and 6. So I'm going to write 5 followed by a parenthesis and then +6 followed by a parenthesis. I'm multiplying row 2 by column 1, so I'm going to fill in the column 1 numbers inside the parentheses. And then finally, row 2 is 5, 6, so I'm going to do 5 followed by a parenthesis and 6 followed by a parenthesis. This time I'm multiplying row 2 by column 2, and column 2 is -5, -2. Now I go back and I follow order of operations. I'm going to do each of my multiplications and then add those products together. So for row 1, column 1, 2 times -3 is -6, plus 4 times 4 is 16, and -6 plus 16 gives me a 10. Then in row 1, column 2, 2 times -5 is a -10, 4 times negative 2 is a negative 8, and negative 10 minus 8 is negative 18. In row 2, column 1, 5 times negative 3 is negative 15, 6 times 4 is 24, and negative 15 plus 24 is 9. Then in row 2, column 2, 5 times negative 5 is negative 25, 6 times negative 2 is negative 12, and negative 25 minus 12 gives me a negative 37. Now, once you get your final answers, we have to put them back in a matrix. I've already stated that my answer is going to be a 2 by 2, so just draw a matrix with enough room for 2 rows and 2 columns. I've got to put the 10, the negative 18, the 9, and the negative 37 in that matrix. Well, if you've labeled what you are multiplying, that tells you where to put your answer. The 10 is going to go in row 1, column 1. The negative 18 is going to go in row 1, column 2. The 9 is going to go in row 2, column 1. And the negative 37 is going to go in row 2, column 2. So let's look at the next example. First, label the size of each matrix. My first matrix has 2 rows and 3 columns, so it's a 2 by 3. My second matrix has 2 rows and 3 columns, so it's also a 2 by 3. These two matrices are the same size. When you're multiplying, the matrices do not have to be the same size. You check the number of columns in the first matrix, which is 3, and the number of rows in the second matrix, which is a 2. These two numbers must be equal. In this case, they're not equal. If those two numbers are not equal, I cannot multiply these matrices. So the reason I can't multiply them is the number of columns in the first matrix is not the same as the number of rows in the second matrix. If I ever ask you if the two matrices can be multiplied and you're telling me the answer, this is what you need to tell me. If they cannot be multiplied, tell me the number of columns in the first matrix is not the same as the number of rows in the second matrix. Don't say the inside numbers don't match, because you've got to tell me what those inside numbers are. Let's look at our next example. My first matrix is a 3 by 3. My second matrix is a 3 by 2. So compare the number of columns in the first matrix to the number of rows in the second matrix. These are equal, so I can multiply the matrices. Now look at the outside numbers, the number of rows in the first matrix and the number of columns in the second matrix. This tells me the size of my answer. My answer is going to be a 3 by 2. My answer will have 3 rows and 2 columns. So once you determine the matrices can be multiplied, I multiply the rows in the first matrix by the columns in the second matrix. So I have 3 rows in the first matrix. Each of those 3 rows have to be multiplied by the 2 columns in the second matrix. So I'm just going to list out what I'm going to multiply. I'm going to multiply row 1 by column 1 and row 1 by column 2. Then I'm going to multiply row 2 by column 1 and row 2 by column 2. And finally, I'm going to multiply row 3 by column 1 and row 3 by column 2. In each case, I'm going to list my row numbers followed by parentheses. So row 1, I have a -2, a -3, and a -4, and place a parenthesis after each one of those numbers. I'm going to fill the column numbers into the parenthesis. So in the second matrix, my column contained a 0, 1, and a 3. Now for row 1, column 2, row 1 is still -2, -3, -4. Put a parenthesis after each one of those numbers. And this time I'm multiplying by column 2, so fill the parentheses in with the elements from column 2, which is 1, 2, and 2. Then move on to row 2. In matrix 1, row 2 is 2, -1, and 0. Well, in the parentheses, fill in column 1, which is 0, 1, and 3. Then for row 2, column 2, row 2 is 2, -1, and 0. Column 2 is 1, 2, and 2. And finally, row 3 is 4, -2, and 3. And fill in the parentheses with column 1, 0, 1, and 3. And then for row 3, column 2, I start out with 4, -2, and 3. And I fill in the elements from column 2 in the parentheses, 1, 2, and 2. So do each multiplication first and then add those results. So in row 1, column 1, -2 times 0 is 0. -3 times 1 is -3. -4 times 3 is -12. Well, -3 minus 12 gives me -15. In row 1, column 2, -2 times 1 is -2. -3 times 2 is -6. And -4 times 2 is -8. Well, -2 minus 6 minus 8 gives me -16. In row 2, column 1, 2 times 0 is 0. -1 times 1 is -1. And 0 times 3 is 0. So I just have a -1. Then in row 2, column 2, 2 times 1 is 2. -1 times 2 is -2. And 0 times 2 is 0. So I have 2 minus 2 plus 0 gives me a 0. Then in row 3, column 1, 4 times 0 is 0. -2 times 1 is -2. And 3 times 3 is 9. So I have 0 minus 2 plus 9 is 7. And then finally, row 3, column 2, 4 times 1 is 4. -2 times 2 is -4. And 3 times 2 is 6. So I have 4 minus 4 plus 6 gives me a 6. Now I need to put these elements back in a matrix. I've already said that my answer was a 3 by 2, so draw a matrix that has 3 rows and 2 columns. Then if you've labeled what you multiplied, that tells you where to put your answers. The -15 is going to go in row 1, column 1. The -16 will go in row 1, column 2. The -1 will go in row 2, column 1. The 0 will go in row 2, column 2. 7 will go in row 3, column 1. And the 6 will go in row 3, column 2. Finally, let's look at how the commutative property of multiplication relates to matrices. If you remember from previous algebra classes, the commutative property of multiplication for real numbers tells me that the order I multiply any two real numbers in does not matter. 2 times 3 is the same as 3 times 2. I get a 6 both times. 5 times 4 is the same as 4 times 5. I get a 20 both times. So when I'm multiplying real numbers, the order I multiply them in, whichever number comes first, does not matter. I'm going to get the same answer. I want to know, is the same true for matrices? So let's let A be the 2 by 2 matrix that consists of 1, -1, 2, 0. And let's let B be the 2 by 2 matrix that consists of the rows 3, 2, and negative 2, 4. So first, let's find A times B. Let's write A first. So if I do that, I have the matrix 1, negative 1, 2, 0 times the matrix 3, 2, negative 2, 4. Well, check the size. These are each 2 by 2. So the number of columns in my first matrix is a 2, and the number of rows in my second matrix is a 2. So I can multiply these. My outside numbers are 2 and 2, so my size of my answer is going to be a 2 by 2. So I'm going to multiply the rows in the first matrix by the columns in the second matrix. So I'm going to end up multiplying row 1 by column 1 and row 1 by column 2, and then row 2 by column 1 and row 2 by column 2. Well, row 1 is 1, negative 1, and column 1 is 3, negative 2. 1 times 3 is 3, a negative 1 times a negative 2 is a positive 2, and 3 plus 2 gives me a 5. Then for row 1, column 2, row 1 is 1 and negative 1, and column 2 is 2 and 4. Well, 1 times 2 gives me a 2, negative 1 times 4 gives me a negative 4, and 2 minus 4 is a negative 2. Now move on to row 2. Row 2 is 2, 0. If I multiply this by column 1, I have 2 times 3, which is 6, plus 0 times negative 2, which is 0. And 6 plus 0 gives me a 6. And then finally, row 2, column 2. Row 2 is 2 and 0. Column 2 is 2 and 4. So I have 2 times 2, which is 4, plus 0 times 4, which is 0. And 4 plus 0 gives me a 4. If I put these back in a matrix, in row 1, column 1, I have a 5. In row 1, column 2, I put my negative 2. In row 2, column 1, I have a 6. And in row 2, column 2, I have a 4. Now let's look at B times A. Let's write matrix B first. So this time I'm going to use the rows in matrix B and the columns in matrix A. So again, I'm going to multiply row 1 by column 1 and column 2, and row 2 by column 1 and column 2. This time my row 1 is 3, 2, and my column 1 is 1, 2. So I have 3 times 1, which is 3, plus 2 times 2, which is 4, and 3 plus 4 gives me the 7. In row 1, column 2, row 1 is 3, 2, and column 2 is negative 1, 0. So I have 3 times negative 1 minus 2 times 0. Well, this gives me a negative 3 plus a 0, which is negative 3. Row 2, column 1, row 2 is negative 2, 4, and column 1 is 1, 2. So I have negative 2 times 1, which is negative 2, plus 4 times 2, which is 8. Negative 2 plus 8 gives me 6. And finally, row 2, column 2, row 2 is negative 2, 4, column 2 is negative 1, 0. So I have negative 2 times negative 1, which is a 2, and 4 times 0, which is a 0, and 2 plus 0 gives me 2. My size here for the answer is also a 2 by 2. So in row 1, column 1, I have a 7. In row 1, column 2, I have a negative 3. In row 2, column 1, I have a 6. and in row 2, column 2, I have a 2. So the question was, is matrix multiplication commutative? Well, A times B and B times A did not give me the same answer. These matrices are not equal. They are the same size, but corresponding elements are not equal. So no, matrix multiplication is not commutative. If you're told to multiply A times B, you've got to write the A first. If you're told to find the product BA, you've got to put matrix B first. If you switch the order when multiplying matrices, you will not get the same answer.